Welcome to VTU Bros Hub. In this video, we cover Module 3, Graph Theory. This is based on the VTU CSE 4th semester CBCS 2022 scheme. We have picked 8 most expected and repeated questions after analyzing 5 previous year question papers. Important note, this module is not repeated as much as Module 1 or 2, so I suggest keep this module for the end of the exam. Let us begin. Question 1. Prove that every circuit has an even number of edges in common with a cut set. This is a theory proof. The concept is, any cycle and any cut set will always intersect in an even number of edges. You can explain this with a simple graph and a short logical explanation. Question 2. Show that a tree with n vertices has n-1 edges. This can be proven by mathematical induction. Base case. A tree with 1 vertex has 0 edges. Assume for k vertices it has k-1 edges. Now for k plus 1 vertices, the tree will have k edges. Hence proved. This is a key property of trees, very useful for objective and theory questions. Question 3. Show that every connected graph contains a spanning tree. A spanning tree is a subgraph that includes all vertices of the graph and has no cycles. Any connected graph must have at least one spanning tree. Explain using a simple example graph. Remove extra edges until there are no cycles. Question 4. In a connected graph with n vertices and e edges, prove that a spanning tree will have n-1 tree branches and a-n+1 chords. Now consider the given graph. Draw 2 different spanning trees. Show that an edge which is a branch in one tree can be a chord in another tree of the same graph. This is a repeated concept question. Use colors to highlight branches and chords for better understanding. Question 5. Find the number of tree branches and chords in the following graph. First, count the number of vertices, which is n. Then count the number of edges, which is e. Now apply the formula. Tree branches equal n-1. Chords equal a-n+1. Highlight branches and chords in the graph clearly. Question 6. Prove that a connected graph G is a tree, if and only if there is one and only one path between every pair of vertices. First direction. If G is a tree, then it has no cycles, so only one path exists between any 2 vertices. Second direction. If exactly one path exists between all vertex pairs, then G is connected and acyclic. Therefore, G is a tree. Question 7. Define vertex connectivity and edge connectivity. Vertex connectivity, denoted as K of G, is the minimum number of vertices to remove, to make the graph disconnected. Edge connectivity, denoted as lambda of G, is the minimum number of edges to remove, to make the graph disconnected. The relationship is lambda of G is less than or equal to K of G, which is less than or equal to delta of G, where delta of G is the minimum degree of the graph. Use an example graph to explain this relation visually. Question 8. Explain the following 3 terms: cut edge, cut vertex, and cut set. A cut edge is an edge, which when removed increases the number of components. A cut vertex is a vertex, which when removed increases the number of components. A cut set is a set of edges, which when removed will disconnect the graph. Use one example graph and highlight these 3 cases clearly. That's all for Module 3, Graph Theory. These 8 questions are repeated and scoring. Use this module as extra. Attempt it at the end in the exam after strong modules. Like, comment, and subscribe for more exam-focused content. All the best for your exams.